So, neurophysiology is broadly classified into three branches. Number one is motor physiology, number two is the sensory physiology, number three is the higher mental functions. The sensory physiology involves afferent information and the ascending pathways. Now let's look at this in detail. When I say sensory physiology, we understand that it deals with the senses. These senses are again broadly classified into two types, the general or the somatic senses and of course the special senses. So the general senses are also known as the somatic senses. Where are these receptors for the somatic senses located? They are located majorly in the skin. But those for the special senses are located in the skull. Please memorize this. The receptors for general senses are in the skin. Those for the special senses are in the skull. Now to name some of these somatic senses, they are touch, pain and temperature. And we all know what are the special senses, right? These are the vision, hearing, taste, olfaction and balance as well. Now let's look in detail about the general senses. The general senses have 4 control points from beginning to their last point of relay. First receptor will obviously be our skin. The first receptor for the stimulus is the skin. From there, along the first order neurons, it reaches the tracts that are present in the spinal cord. And from the tracts in the spinal cord, along the second order neuron, they reach the relay center, that's nothing but the thalamus. The second order neurons carry the information from spinal tracts into the thalamus, and finally with the help of the third order neurons they reach the sensory cortex. So from the skin to the spinal cord and spinal cord to the thalamus and thalamus to sensory cortex. So in your exam you will be asked which order neurons transmit the information from skin to spinal cord or thalamus to sensory cortex or anywhere among these. Now let's look at the receptors and what they function for. The first one is mechanoreceptors and they function for touch. Nociceptors, as the name suggests, it is for pain. Thermoceptors similarly is for temperature. Proprioception is for the position sense of the joints, and exteroceptors, extero means for external stimuli. For example, these are nothing but again these mechanoreceptors. Then interoceptors are for internal stimuli such as the osmoceptors, and telereceptors are for distant stimuli. The main example is the photoreceptors present in the eye. Now, these receptors are again classified based on the speed of adaptation to stimuli, right? So, when I say speed, either they can be rapid or slow, right? So, they can either be rapidly adapting receptors or slowly adapting receptors. The rapidly adapting receptors, as the name suggests, adapt quickly to the stimulus, whereas the slowly adapting receptors adapt slowly. The examples, you can easily remember that all the types of corpuscles are mainly rapidly adapting type, whereas the remaining receptors, that is the Merkel cells, the raffinase endings and the free nerve endings, all of these are the slow types, that is the slow adapting receptors. Now let's look at some interesting properties of receptors. These are mainly the modality, the location, the intensity and the duration. Coming to the modality, by that word I mean what type of stimulus they respond to. So, the example for this I can give is pain is the type of stimulus which is perceived by the nociceptors, right? Now the second one is the location. The majority of the receptors are located in the skin, and two terms we have to memorize over here are the receptor field and receptor density. Now receptor field is the specific area in which a receptor responds, that is the response area of a receptor, right? But the receptor density means Easy to understand, it is the number of receptors. So receptor field is nothing but the area in which it acts, whereas density is the number of receptors. Now high receptor density is seen in lips, fingertips. Here they help in short 2-point discrimination distance. That is, suppose my points of stimuli are so close, even that these areas can easily differentiate as two different stimuli. That is due to high receptor density. Now low receptor density is present in trunk and hips. You can understand that it can only discriminate far 2-point discrimination distance, right? Now the next property that we are looking at is the intensity. The receptors increase frequency of action potential in response to the intensity of the stimulus. So, when there is less intensity of the stimulus, then the action potential is also generated with a lower frequency. When the stimulus has a higher intensity, the action potential will have higher frequency. And the duration, kindly look carefully over here. It is the time interval between the start and stop of the response. That is the duration. That is nothing but how long the receptor is active for the given stimulus.